Hi students, I want to do some more examples of the ellipse for you. I'm going to start with this number 5 right here, and I'm going to rewrite it like this. X minus 2 quantity squared over 16 plus y plus 1 quantity squared over 1 equals 1. Now it's in standard form because there's nothing but binomials in the numerator and the constant is 1. So the first thing I'm going to look for is the center. So looking for the center, it is 2, negative 1. So I like to kind of make a drawing here. That's not to scale. And now look, where is the A? Where's the denominator, the biggest, and it's under the X? That means my ellipse is going to have a horizontal major axis. It means it's going to be wider than it is tall. So in other words, the 16 is my A squared and the 1 is my B squared. So let's start with finding the vertices, which are the endpoints of the major axis. It's going to go 4 in each direction. So from 2, negative 1, if I go left 4, 2 minus 4 is negative 2, and the y value is still negative 1. And to go 4 in the right direction would be 6, negative 1. So there are my vertices, and I can write this down. Now let's find the co-vertices, which is going to be on the y-axis, and it's going to be the short one, and the square root of 1 is still 1. So counting off from the center, the x is going to be the same, but the y is going to go up 1, so it'll be 0, and it's going to go down 1, so it'll be 2, negative 2. So there are my co-vertices. Next, I'm going to find the foci. Now the foci, I have to do a little bit of math for. I take a squared minus b squared to find c squared. The foci, the value I'm looking for though is c. So 16 minus 1 would be a squared minus b squared, and I would get 15. So it must be the square root of 15 is equal to c. I just looked that up, and that is about 3.9. So now remember, the foci have to be on the major axis. So from the center, I'm going to count over 3.9, and 2 minus 3.9 will be negative 1.9 on the x, and the y, because it's still here on this axis, is negative 1. And then to find the 1 on this side, it's 2 plus the 3.9, which would be 5.9. And again, my y is unchanged. So here's my two foci, if you will. Now finally, I need to find the eccentricity, which is c over a. And I just established that c was 3.9. A is the square root of the big one, is 4. Look how close to 1 that is. That is actually 0.975. Because it's pretty long. I didn't draw it to scale. All I do the points for is just kind of orient myself. I don't typically draw the ellipse because I'm just trying to keep those x's and y's correct. So there's one example. Let me do another, please. Okay, however, this time, look at these equations. They don't look they're not in standard form. I know that they're ellipses because the x and the y are both positive, they're both squared, but they have 2 different coefficients, so I know that these are ellipses. But I'm going to have to do some work to get them compatible with the standard form. So I think I'll choose this one, number 17. And the first thing you do is you need to write them and group the x's together and the y's together. So I'll put 6x squared plus 18x plus 2y squared minus 10y, and I'm going to move the constant to the other side because I'm going to be completing the square. Now, most students are going to look for the greatest common factor. Don't do that. I need you to pull out whatever is that coefficient with the x squared. It's coming out. So 6 comes out, and that leaves me x squared plus, take the 6 out of the 18 as well, 3x plus blank. Okay, I'm setting up this to complete the square for the x's, and I'm going to do the same for the y's. Plus, and the coefficient's 2, so it must come out y squared, and I divide it out of the y term, the linear term as well. 5y plus blank is equal to -2. Now I'm going to complete the square. I take the linear term divided by 2, which is 1.5, and I square it, and that's 2.25. However, I'm not just adding 2.25, I'm adding 2.25 times 6. So 2.25 times 6 is 13.5. So if that's what I'm really adding to the left, I must add it to the right-hand side. Now let's do the y term. -5 divided by 2 is going to be 2.5. When I square that, that's 6.25. But 6.25 times 2, because I had to multiply it by that constant that I pulled out, is 12.5. Now let's clean this up. I created this perfect square trinomials. I need to factor them, but don't forget that 6. That's 6 times x plus 1.5 quantity squared plus 2 times, y plus 2.5, that's a negative, y minus 2.5 quantity squared is equal to 12.5 plus 13.5 minus 2 is 24. Now here's the deal. This is 24 and it's supposed to equal 1. So I'm going to divide everything by 24. Every term gets divided by 24. Because my goal is twofold. I need to make this constant 1, and I also need to get rid of those coefficients. Those binomials, those numerators need to just be the binomials by themselves. So on this, 6 over 24 is the same thing. 6 will divide by 6, and so will 24. So I get x plus 1.5 quantity squared divided by 4. I just simplified the 6 over 24. Plus y minus 2.5 quantity squared over 12, I divided that by 2 and that by 2, is equal to 1. So here is my standard form. Okay, I'm just going to go through this real quick, not explaining, if you will pause and do all those essential points, the attributes, and then check against mine. Let's see how you do. So pause, and here are the points I'm going to go for. I'm going to pause again and just write the answers. And there are my values right there. I hope this helped. You guys take care.